So hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we are going to go through a couple of popular physics question and answers. These questions are going to be at the high school and university level, and a little bit background about myself. So I am in the final year of my graduation and I am doing my graduation in aerospace engineering. And if you need any homework help, or if you need any tutoring help, or if you need any one-to-one live sessions, then you can check the links in the description below. And I'll just start with the lesson today. So this is new section, and so we have question number one. It is asking, find in the diagram the equivalence capacitance of the network, the charge in each capacitor, and this question is again and again repeating. So I'll just draw the diagram first. This, and then we have a resistance type. Well, the sign of capacitor is not this. I'll just use the correct sign. I'll draw this with lines. And I'll use one more line and I'll copy this and paste it. This will come here, and this will come here, and this line, copy paste, this will come here, and I will just clear the extra part. And one from here, here, and from here, and that is all. And for battery also. So here is one capacitor. This is a battery, capacitor, and capacitor. So this is 5 microfarad. This is 12 microfarad. This is 16 microfarad, and this is 12 volts. And yeah. So the formula for calculating charge in a capacitor is basically Q is equal to C into V, where C is the capacitance and V is the voltage and Q is the charge. Now the thing, here we do not have any capacitor. Just close this. So here we can see that this 5 microfarad capacitor is in series with parallel combination of 16 and 12. So in the case of resistance, when we have it in parallel, then we take the reciprocal, but in capacitance we have the opposite. So what we'll do, we'll sum. So for total capacitance, um, parallel ones are 16 and 12. So we'll add 16 plus 12, and this will be 8 to 28, and then 5 and this 28 are in series. So we'll have 1 over 5 plus 1 over 28 is equals to 1 over C equivalent. Then 28 plus 5 over this will become C equivalent will be, this will be 5 into 28 over 5 plus 28. C equivalent will become, this will be approximately 4.24. Use the formula Q equal to dV. So Q will be, so the total capacitance, we have done the A part, equivalence capacitance of, and this will become 50.9 microcoulombs, because this was in microfarad, so this will be in microcoulomb. And then we have so basically I'll just go up. So for this one we'll just use this formula again. So total for 5 microfarad, total charge is 50.9 microcoulomb and capacitance is 5 microfarad into voltage. So we'll just divide 50.9 over 5 and we'll get the voltage as, this will be 50.9 divided by 5, this will be 10.18 volts. And now since the voltage, total voltage difference is 12 and voltage drop across the 5 microfarad capacitor, which is this one is 10.8, then voltage drop across this parallel circuit will be the rest of the potential difference. So we can just subtract this and we'll get 12 minus answer. This will be 1.82 volts. The potential difference across this circuit is 1.82 volts. So let's just check the solution given here. 1.82 and then we have 10.18, so yeah, with very less error. So the solution given here is correct. Good work. Now we have question number 2. So we have been given this circuit, so I'll just quickly draw this circuit. For this I will take this kind of shape and we have one line from here and one from here. So shapes, one line from here and one from, let's say, here. This will be, here we'll have register here, and this is not connected, and this one, here we have a battery, So this one is 6 volt resistor, one here, one here, and we have an open switch here. This is 1, 2, this is R1, R2, and this one is R3. So what I will do here, so a 6 volt battery supplies current to the circuit shown. When the double throw switch S is open, as shown in the figure, the current in the battery is 1 milliamp. So for case 1, this switch is open, so current will pass through this resistor, it will not pass through this branch, and it will go from here and from here. So for first case it will be like, and then from here, then from here, this will be R1, R2 and R3. So we have for the resistance one, we have the equation V is equals to IR, and for the this condition we can see that R1, R2 and R3 are in series. So R equivalent will be R1 plus R2 plus R3, and we'll just put this R equivalent in this equation. And for the first case, the current given here is 1 milliamp, and V is 6 volts. So 6 divided by 1 milliamp will be 10 power minus 3 amp, and this will be R equivalent, which will be R1 plus R2 plus R3. So this will become 6000 equal to R1 plus R2 plus R3. Let's say this equation as A. Now we'll go for second condition. When the switch is closed in the position 1, in this case, then the current in the battery is 1.10 milliamp. So again I have 6 volt here, then I have one resistor, then this one, and this is connected. So in this case, the current will not go in this R3 because the current will take the shortest path, and the minimum, no, sorry, the current will go, yup, that will be for third one. So current will go in R3 also, so I will include R3. So this was R1, R2, R2 and R3. So here R equivalent will be R1 is in series with a parallel combination of R2 and R3. So here I'll just simplify this. R1 is in, let's say this as series with the parallel of R2, two R2s, this one and this one, and this combination, this parallel combination is in series with R3. So I can say for parallel 1 over R2 plus 1 over R2 is 1 over R2 dash, So R2 dash will be R2 square over 2 times R2. This and this will get cancelled. R2 over 2, and I have R1 plus R2 over 2. So this is the equivalent of this parallel combination, this term, and then we have R3, which is our equivalent here. And again we are going to use this formula, V is equal to IR, then V by I, 6 volt over 1.10 into 10 power minus 3 R1 plus R2 by 2 plus R3. So I'll just use my calculator. 6 divided by 1.1, this will be 5454. This will be 5454 equal to R1 plus R2 by 2 plus R3. So this is our B equation. And we'll move for third case. So in the third case, the switch is connected in the 2 position. We have 6 volt here. Current will go from R1 and then it will go from if this switch is connected in this direction, then current will come from here, and it will take the shortest path. So instead of going through the resistor, it will go from this branch. So the circuit will be like R2, then we have this 2, and here this current will not go in this direction because it will take the shortest path. So here we have only R1 and R2 in series. So R equivalent will be R1 plus R2, and again V equal to IR. So we have V equal to IR, 6 over 1.9 into 10 power minus 3 is R1 plus R2, and this will be 6 divided by 1.9. This is 3.1. This is 3157, which is R1 plus R2. So this is my C equation. Now I'll just put R1 in terms of R2. So R1 is 3157 minus R2, and I'll put this in A and B. So I'll put the value of R1 in A and B. So my A was 6000 is sum of 3. So 6000 is R1 is 3157 minus R2 plus R2 plus R3. Okay, so R2 and R2 will get cancelled, and here we have 6000 minus 3157. So this will be, no, 6000 minus 3157, 2843. So my R3 is 2843 ohms. Now I'll calculate, I'll put the value of R3 and R1 and in I'll put the value of R3 in equation B. R3 was 5454 equal to R1 plus R2 by 2 plus 2843. This will get subtracted. So 5454 minus 2843. This is 2611 equal to R1 was 315. R1 was 3157 minus R2. So 3157 minus R2 plus R2 by 2. So this will go on this side. So 3157 minus 2611, 546. This will be minus because this will come here and it will be minus, and this will be minus R2 by 2. So minus minus will get cancelled, and into 2 this is 1092 ohms. 3157 minus answer, this is 2065 ohms. So I'll just cross check the solution given by Junior Tutor, and this 2067. Okay, then we have 1091, and then we have 2842. So there is a little bit of error which is acceptable, because here they have taken till 2 decimal places, but I haven't taken any decimal place. So this is pretty much acceptable. And yeah, the solution given here is correct. So I'll just write correct solution. Good work. Solution is correct. This will be question number 3. So question number 3, we have a missile is fired across level ground at an angle of 37 degrees to the horizontal and remains in the air for 7.6 seconds. So let's say I'll draw one axis here. So let's say this is the vertical and this is the horizontal, and I'll just draw it with a pen. So this angle made by the missile, let's say it is 37 degrees. So this is my missile, and this angle is 37 degrees, and it is given the time it remains in the air is 7.6 seconds. This is going to be a projectile motion, and 7.6 seconds is its total time travel, which is 7.6 seconds. And what is the initial velocity and range of the missile? So for velocity, so for total time we have formula 2u sine theta over g, where u is velocity, g is acceleration due to gravity, and theta is this angle. So this is 7.62 times u times sine of 37 degree over g is 9.81. So we'll just rearrange this equation to evaluate this in terms of u. So this will be 7.6 into 9.81, 2 into sine of 37 degrees. So 7.6 into 9.81 divided by 2 divided by sine of 37. So my velocity comes out to be 61.942 meter per second. So let's check the velocity. This is 61.88. Okay. So here they have taken the acceleration due to gravity is 9.8. I have taken 9.81. So it can vary in the decimal places. Now for range. So range is nothing but the distance traveled in x direction. So this is the range. So for range, we have the formula as u square sine 2 theta over, it was 2g or g, yeah, it was g. Velocity 61.942 whole square, then we have sine of 2 into 37 over 9.81. So again I'll use my calculator. So answer square into sine of 2 into 37 divided by 9.81. So this is, range is 375.968 meters. And again here the range given here is 375.6. We have again taken the velocity was different, and the acceleration due to gravity was also different. So we took for 2 decimal places, and then therefore our velocity was different from the one which is obtained here. And then squaring the term will again, like, it will create some error or some difference in the answer, but the procedure is same. And if these integers are equal, then yeah, this answer is also acceptable. So 375, 375. Okay, so answer given here is correct. Solution. Good job. One, two, three, four. We have question number 4, and this one looks like a lengthy one. So a door 1.4 meter wide and 1.9 meter high, weighs 310 Newton and is supported by two hinges. One 0.5 meter from the top and the other one 0.5 meter from the bottom. Each hinge supports half the total weight of the door. Assuming that the door center of gravity is at its center, what are the horizontal components of the force exerted on the door by each hinge? So here in the solution we can see the diagram. So the upper hinge is 0.5 meters and the lower hinge is also located at zero point 0.5 meters from the bottom. Weight is given here 310 Newton and we have this arrow pointing in downward direction because weight is in downward direction. This is the total height given, which is 1.9 meters. And so I'll not draw this diagram, but I am going to use this. So the total weight, what we are going to do is that we are going to use the condition for static equilibrium. So in this case, summation of horizontal forces will be 0. So horizontal force we can see which we have H1 here and we have one H2 in the opposite direction. So H1, then H2 is in the opposite direction, so this will be 0, hence H1 is equal to H2. Then we'll use this static equilibrium. I think we'll be using momentum gap. We'll be using momentum here. So in the case of static equilibrium, the momentum about any point will be 0. I'll just cross check. Yeah, the momentum about any point is 0. So if I take momentum about summation of momentum about CG and this will be 0. So this is the CG and we'll take anti-clockwise as positive. So this is the CG and so let's start with this weight. The weight is acting on the CG point. So weight and okay. So in for the weight one, the force is going through the point of concentration or the point where we are taking the momentum or calculating the moment. So this will become 0. So this force will not contribute in the moment about CG. Then we have horizontal force and we need this much distance. So this is 1.9. This is half of 1.9 which will be 9.5. So this upper half will be 9.5 and minus this will be 0.95 and minus 0.5, so this will become 0.45. So my H2 and this distance is, I'll just draw this. So this was the door, this is H2 and this is the CG. So this distance is 0.45 and we can clearly see that. So the moment will be force into perpendicular distance and this will be in clockwise direction. So H2, I'll add a minus into 0.45. Then H2 is done. We'll go for V2. So V2 is I am not sure that V2 will be, we should be writing, yep, okay. So basically if we take the forces for if we take the summation along vertical forces, then we have one vertical force which is downward direction. This will be minus 310 Newton. Then we have hinges and it is given that each of the hinge supports half the total weight of the door, so it is directly given. So it can be 2x equal to 0, then x equal to 1.155 Newton. So each hinge is having 155 Newton in y direction. So if I go for V2, so V2 will have this, and the perpendicular distance is 0.7, so this will cause anti-clockwise. This will be plus 155 into 0.7. Then we'll go for H1. So again here we have H1 and this distance will be 4.45 and it is causing a clockwise. So we'll have minus H1 into 0.45 and then we have V1. So V1 is this and this is 0.7, so this V1 will cause 155 into 0.7. This will be 0. So we can clearly put this as H1 and H2 is equal, so this will be 2 times H1 and this will be equal to 2 times 155.7 and 0.45. So this 2 and 2 can get cancelled and this will be, so 155 into 0.7 divided by 0.45, so this will be 241.11 newtons. And let's just check the solution. Yeah, so 241.11, and as H1 and H2 are equal, so H2 will also be 241.11 Newton. So this is pretty much all for this question, and the solution given here is correct. Correct solution. Good work. One, two, three, four. This will be question number 5. Okay, so an air plug of mass 0.331 kgs, which is this one, is tied to a string and allowed to revolve in a circle of radius 0.82 meters on a horizontal frictionless table. So friction is 0. The other end of the string passes through a hole in the center of the table and a mass of 158 kg is tied to it. The suspended mass remains in equilibrium while the plug revolves around it. The acceleration of gravity is 9.8 meter per second square. So we need to find what is the tension in this string and what is the speed of the plug. So for tension, we can use the condition of static equilibrium. So here we have, let's say this is the plug and this is the 1.58 kilos bar. So this is going to be the tension and weight is going to act in this direction. So I can use the summation of I can use the condition for static equilibrium, which is summation of vertical forces is 0. So I can say tension is going to be equal to weight. V is 1.5 into 9.8. 1.58 into 9.8. This will be 15.484 and newtons. So let's check this part. 15.484 Newton. Okay, correct. Now For the B part, we need to find the speed of the plug. So the basically we need to find the speed of the plug. Yeah. For speed of the plug, the radius is given as 0.82. So I can say that this tension, this when this plug is rotating, then it is experiencing a centripetal force which will be in outward direction, and this centripetal force is counterbalanced by this tension in this string. Therefore, this plug is able to rotate in this circle only, and it is not leaving the circle. So I can say that centripetal force is equal to tension, and this force is mv square by r, which is equal to tension, which we already calculated, 484. Then we have the mass. So mass is 0.331 v square over radius is 0.82, and this is 15.484 newtons. So V will be under root of 15.484 into 0.82.331 multiplied by 2 divided by 0.331, then under root of answer. So velocity is 6.193 meter per second. So let's check the velocity given. Mass of the plug v square by rt, so 6.193. So yeah, in this way we use the condition for, or we use the benefits of static equilibrium. And this is pretty much all for this question. The answer given by junior tutor is correct. Work. Now I will go for question number 1, 2, 3, 4, 5, 6. This was question number 5. Okay. I think I had a disconnection, but everything seems to be working fine now. Yeah, so this was question number 6. So this will be question number 6. So a thin, long conductor of length 60 centimeter connected to a battery of EMF 12 volts and internal resistance R equal to 0.8 ohms carries a current I. The long conductor has a resistance of 5 ohms. The wires that are connected, the wires that connect the conductor to the battery have negligible resistance. Consider the point P at a distance. What is the direction of magnetic field B created by the point I at at point P, and what is the magnitude of this field? So okay, so first we'll find the equivalent resistance. So here we can see that this small r, which is the internal resistance of this battery, is connected in the serial direction, or it is connected serially with the um, resistance of this long wire. So we can say equivalent resistance is 5 plus 0.8, and this is 5.8. 0.08 ohms. Then the we'll find the current. Current is V by R. Voltage is given as 12 volt, and resistance is 5.08. This will be 12 over 5.08, 2.362, 2.362 amps. Then we have the current through the circuit, the total resistance of circuit, and then we have current, which is okay, I did a mistake. This will be 5.8. I wrote it as 5.08. 5.8. I'll just correct this current also. This will be 2.07 amps. And then what we'll do, this is the long wire. We'll take, so it is assumed that the point P is located at half the distance, which is 30 centimeter from here and 30 centimeter from here. And we have these angles, which is theta 1, and we have this one, which is theta 2 meter. So the distance D is given as 5 centimeter, and what is the direction of current? Is the magnitude of field. Okay, so the magnetic field at point P on a long current carrying conductor can be given by mu naught I over 4 pi into the distance D, and we have sine of theta 1 plus sine of theta 2. So here we can easily calculate the sine of theta 1, and as this theta 1 is equal to theta 2, so this can be easily calculated, and B will be mu naught is the magnetic permeability of free space, so 4 pi into 10 power minus 7 over 4 pi, distance was 0.05 meter. Then we have current, and when we take the tangent inverse of this, then we'll get theta as 80.54. I will do the 2 times sine of 80.54 degree, and this will become, B will be 81.67 into 10 power minus 7 Tesla. Now the magnitude of magnetic field is this, and the current, for the direction of current, we can see that the positive side of the battery is connected to the top of the conductor, which means the current is flowing from top to bottom. And when the current is flowing from top to bottom, we just use the right hand rule. So the current is flowing from top to bottom, then magnetic field will be in. If we see from top, then it will be in the clockwise direction, and this means that the direction of the magnetic field at point P is perpendicular to the screen and inwards. So that is pretty much all for this question. The solution given here is correct. Good job. Now we'll have question number 7. So in this question, a massless horizontal strut is attached to the wall at the hinge O. So this is the strut. What is the force that the hinge pin applies to the strut if the weight of the cable is also neglected? So I'll try to draw this diagram. Um, I'll draw a triangle. It is better to draw a triangle. Then I'll draw one line and I'll erase the extra part. So, and this is 10 feet. This is the strut, which is 5 feet, and we have a mass of 100 pounds hanging here. Okay, so let's say this is the tension in the string, and I'll just draw the point force diagram. So at this point we can see mass is acting in this direction, so this will be mg. Then tension is in this direction, and I need this angle. So for this angle I can write tangent theta, let's say theta is 10 over 5, which is 2. So tangent inverse of 2 will be 63.43 degrees. So my theta is 63.43 degrees. Let's say this is the horizontal and this is angle theta, and I'll take the components of this tension. So this will be T sine theta and this will be T cos theta. And we can see that the force which is applied on this strut is going to be the reaction force of this strut, and this reaction force is going to be caused because of this T cos theta component. So reaction force will be in this direction, let's say R. So we need to calculate R, but before calculating R we need to calculate T. So I'll use the condition of vertical equilibrium. I can write T sine theta equal to mg. T is mass is 100 lb and acceleration due to gravity is 32 feet per second square in FPS system, and we have sine of 63.43 degrees. So tension will be 100 into 32 over sine of 63.43. So this will be 6932.110, and this will be pound force. Now we have the value of tension, and from horizontal equilibrium I can say R is T cos theta. So I'll just multiply cos theta in this, so into cos of 63.43, and this is 3100.669 pound force. I'll just let's just check the solution given by junior tutor. Mm, so they have taken this angle for calculation. And then again they are using equilibrium for vertical, for horizontal, and then they have calculated tension. Um, but here they are putting W as 100 lb. So remember one thing, that if it is given only lb, then it is not pound force, it is basically the mass of the system. We always need to multiply this with the acceleration due to gravity, but whenever it is given in lbf, then it is definitely the pound force. But here lb is not given with either f or m, therefore lb is going to be taken as mass. Here they have taken as weight, but we are going to multiply this 100 lb with the acceleration due to gravity. Calculate the weight. Therefore, the answer given here is incorrect, but the procedure was correct. So I'll just write incorrect answer. Incorrect answer. Um, Here mass of block is given as 100 lb, not weight. Whenever it is given in lb, then it is always mass, and when it is given in lbf, then it is force or weight. So here they had to multiply 100 lb with 32 feet per second square. Hence, um, force on strut will be 3100.669 lbf. I'll just put this in quotation mark. Yup. The solution given here is incorrect, and this is the correct way of solving these kinds of questions. We always have to multiply mass with acceleration. We cannot take the mass as weight of the system or the block. So that is, yeah, so that is pretty much all for this session. And if you like this session, then please do hit the like and subscribe button also, and you can hit the bell icon to stay updated for our next live streams. And if you have any homework, if you need any homework help, or if you want to submit your own questions, and if you want any tutoring help or one-to-one live sessions, then you can check the link in the description below. And this was Devansh Purohit, senior tutor at OneClass, and I hope to see you soon in my next video. So till then,